Hello and welcome to Core AVI's inaugural podcast series where we take a look at how safety is shaping the future of AI and autonomy. I'm your host, Mary Beth Behrens, and I'm the Director of Marketing at Core AVI. I have here with me today Neil Stroud, the Vice President of Marketing and Business Development. Hi, Neil.
Hi, Maribeth.
We've got Dan Jonkis, who is the Chief Sales and Marketing Officer. Welcome, Dan.
Hey, thank you, Mary Beth.
And Damien Fauser, the CEO of Core AVI. Hi, Damien.
Hi, Mary Beth.
Okay, so let's start by taking a look at some market trends. According to Statista, in 2019, there were already some 31 million vehicles with at least some level of automation in operation worldwide. And this number is expected to surpass 54 million by 2024. According to Business Wire, the autonomous car market size forecast for 2030 is 60 billion, with Audi alone planning on spending 16 billion on self-driving cars by 2023. And not only that, according to the Wall Street Journal, autonomous vehicles are projected to reduce traffic fatalities by a whopping 90%. So, with these market forecasts and potential benefits, the first most obvious question would be, why do I still have to drive my own car?
I think it's a really interesting question, and it was one that was put to an audience by a gentleman called Burkhard Hunk at an embedded vision conference a couple of years ago. And it's significant that he was the person who put that question because he was the engineering lead on the Team Stanford project that won the DARPA challenge to drive across the Gobi Desert. So here's a person who, at that point, had spent 14 years working with autonomous vehicles, and he was reflecting on the thought that when they set out to do the project, they figured by now that we'd have autonomous vehicles. And one of the things that they realized is it is actually a lot harder than they'd anticipated. And the bit that's a challenge is going from building project cars to um, scaling for mass production. There are a lot of challenges that you don't have when you're trying to solve the problem for one car that as you start to imagine thousands of cars on the road, all of a sudden the problem becomes much more difficult. And um, the big challenge I think is safety in the widest possible definition of that word. And by that, really, we're thinking about things like robustness, predictability. It's interesting. We have an intuitive understanding what other drivers are going to do on the road. You know, if we look at another driver and we make eye contact or see head position, we can learn a lot from that very, very small, subtle social glance. You take that out of the equation, and all of a sudden you're into the unknown. So I think the realization is that this is a massive technical, social, infrastructural challenge, far beyond the scale of what people imagined when they were looking at it from just the how do I make this car drive itself perspective.
I think it's interesting as well. It's a mindset shift as well. I think, as you said, Mary Beth, there's a lot of analysis around the number of people who are willing to entrust their lives and their family lives in a fully autonomous vehicle as well, right? So there's that whole thing you've got to wrap your head around. And maybe to go back to your original point, why am I still driving my own car? I still want to drive my own car. I mean, you guys know me already. I'm a petrol head, and I don't necessarily want that taken away from me. I know we're many years away from full autonomy and millions and millions of autonomous vehicles on the road, but I still want the option to drive my own vehicle until I'm unable, and then of course I'm all in on autonomous.
I think all of this also comes down to, yes, it's willingness to adopt the technology. I think it's also, of course, legislation, it's infrastructure. A lot has to change to have fully autonomous vehicles on the road. And of course, to Damien's point, the safety aspect means cost, massive cost to build the technology to be truly safe, to be deployed. And I think this also leads us to looking at, return on investment and where do you focus i- the technology development in areas that show real economic value first. So if you look at trucking, drone delivery, air taxis, to me, those are the low-hanging fruit that the cost and investments need to drive the technology because you see a real economic return.
I think we can think about, the idea of the introduction of seatbelts. That was something that was resisted in cars. It took a long time for that to be kind of normalized. And if you think about that mentality, the fact that safety as a standalone idea doesn't necessarily have value either to the car buying public or to the car manufacturers as a differentiator. Um, and if the big reason behind why the car wants to drive itself is to reduce accidents and deaths, that to Dan's point, that may actually perversely not be an economic driver in and of itself. There needs to be a lot of other things coming to the fore to make this economically viable, such as not having car ownership, cars as a service, as opposed to the concept that we all own a car that sits in the garage. So the the point there is there may be even beyond just can we make the car safe, can we persuade the public that it's safe, and then can we persuade the public to look at vehicles and cars as a completely different thing, as a commodity service, as opposed to something that you own?
It's interesting as well with the next generation. As I talk to my 14-year-old lad about driving a car, he has no interest in driving. He wants to get from A to B, but he doesn't necessarily want to be in a position where he wants to drive himself. He just wants to jump in a ride-hail service or whatever that looks like in the coming years. So I think our generation, it was all about, you get behind the wheel as soon as you possibly can, and that gave you your freedom, and it was a status symbol of owning a vehicle. I think it's a massive disruption that's coming, and the newer generations just don't, they're focused on other things.
I have to agree with that. My 16-year-old has his beginners, has no interest in driving. And his first few attempts on the road, he looked at me and he said, you really have to pay attention to what you're doing. This is a lot more difficult than I thought. I think there's some obvious benefits to deploying certain elements of AI in the short term in vehicles like battery monitoring, predictive maintenance, smart traffic management. Like I think there's some return on investment you'll see by bringing those types of AI elements into the vehicles. But of course, as we're discussing here, it's going to take some time for true autonomy. So then the question is when. I have some Gartner stats. So Gartner forecasts, just some data points. Gartner forecasts by 2028, 1/5 of the world's countries will have active regulations that allow production-ready autonomous vehicles to operate legally. By 2026, sensor costs to deliver level 3 and above autonomous driving functionality will be approximately 25% lower than they are today. And by 2025, for mainstream use cases, autonomous vehicle perception algorithms will be proven to be an order of magnitude better than human drivers. And that's up from where we are today, where these types of algorithms are less capable than human operators.
Interesting stats. So having worked in this industry for a few years, I think we've all seen, the analysts being very aggressive in the early days to how quickly we're going to see mass deployment of autonomous vehicles, to having a significant rethink and pushing it out towards the end of the decade. It sounds like from those Gartner stats that we're actually getting a bit more optimistic again, and those deployments are going to happen sooner. What do we think is causing that?
I think what you're seeing there is the individual elements are being solved. And I actually think that is the low-hanging fruit in terms of solving the problem. If you just simply focus on the algorithm, or you focus on the sensor um, capability, um, that is um, that's the area where the progress is definitely being made. The the challenge comes back to when you have to put all of those different elements together and then engineer the structure, but also um, uh, make the combination of individual components and parts safer than the performance of every individual element. Um, and that overall kind of safety minded system and system of system development is something that's uh, not in the DNA of the way cars are made right now. You know, the cars are very distributed. They're very independent system minded kind of engineering, and this is a whole shift towards building the car as a single system, and a single integrated unit. So I think that it's good to know that those challenges that are being met in those individual areas, how that all comes together, and how the investments in those individual areas are maintained over a long period of time. And again, that goes slightly against the way previous vehicle engineering has been done. Um, Going back to some of the stuff that's out there, you know, we're looking at the rise of the concept of the software-defined vehicle, and that is almost that's almost a prerequisite to some of the things that we're talking about in autonomy. You know, if you haven't got this, you haven't got a framework on which you can put a software engineered driver, then you can't evolve the capability of the car, because every time you go to upgrade your driving AI and systems, you're re-engineering the car, and that can't be the way that it's done. So I think it comes back to this to two concepts we see a lot of across all industries when it comes to safety. One is the pathway to safety from prototype and problem solving engineering to the system engineering and implementation. Um, and we know that is a significant challenge in and of its own right.
But I think underpinned on this all is $16 billion has been spent on self-driving car research. So when you look at combined outlay of cash by automotive OEM startups, established companies, $16 billion has been spent so far. This is at a minimum on self-driving car research,
But that could ultimately be a drop in the ocean compared with what's needed.
Yeah.
especially when you add the safety aspects. So that's research. That is like, designing machine learning, deep learning. That is not addressing really what we believe is the trigger to bring it to mass autonomy, which is the secure and safety platform. It's interesting. Is there some type of safety standard that Tesla has announced in conjunction with this? Like, is anyone aware of ISO 26262 or other safety standards that these systems have achieved?
I think you've highlighted a problem there, Dan, because I think the industry's only just kind of coming to terms with ISO 26262 as a base standard, and that's before we start putting things like machine learning and artificial intelligence on top of it that really it was never intended to be used for. So I think that's challenge number one. And we know from the conversations, right, a lot of the automotive OEMs are just kind of coming to terms with adding safety to their autonomous systems that they've been prototyping. We know they're driving around with safety drivers there ready to grab the steering wheel as it disengages, and we know the disengagement miles are increasing and getting much better. But it's definitely an interesting one. So there are new standards emerging like SOTIF, so safety of the intended function, to look at that higher order operation and safe operation of the vehicle, and that's trying to encompass some of this autonomy and AI kind of functionality, but we're not there yet as an industry.
So do you think any of the investments into the compute algorithms in SpaceX has been utilized across other Elon Musk's business like Tesla? Because it's pretty impressive what they can do with aircraft, landing in the exact spot. And obviously, there's a lot of compute capability there, do you think there's cross-pollination of these technologies across those businesses?
I think for sure. With the automotive conversations that I've been having, I think avionics generally is looked at as the pinnacle of safety. We don't think twice about jumping in a plane and it getting us safely to our destination, and just the sheer number of miles that are flown by all of the flying things out there. It's an extremely low risk of something happening. So I think that's exactly what the automotive guys are trying to comprehend, is how they can take that goodness but cost optimize it, form factor optimize it to fit into a vehicle, and get to the same levels of safety.
So that makes a lot of sense for us, coming
Mm-hmm.
from certifying avionics systems for many, many years. That's why I asked that question, because you got to believe the problems that we have solved and continue to solve in the avionics market certainly has meaning and applicability, across all these other markets that we are supporting.
It's very interesting to see parallel industries. So if we think about urban air mobility as being, the almost the love child of autonomous vehicles and flight systems. If you had to pick something that fell between the two of them, it would be the technical challenges of the urban air mobility solutions that are out there, which tend to be engineered in a avionics manner when you come to building the systems, but are building AI models very much in that more exploratory prototyping kind of environment. And we're now seeing them uh, facing the challenge of bridging those two different worlds of technology, bridging from stuff that has been built often in highly optimized proprietary ecosystems, tool chains, technologies that don't lend themselves to being implemented in a safe way because they can't replicate discrete or consistently show robust discrete operations. And then they have to get from the what they have learned there, what they've built in the application in those environments, to safe systems that can be certified, that can meet the existing regulations for the discrete parts, but adopt new regulations for the AI and human function replacement technologies. So we're seeing the same problem from different sides in lots of different areas. It's interesting you mentioned 26262, because it was, I don't think anybody ever imagined it as a standard for autonomous vehicles, or even the levels of technology that you need. Um, I think, you know, traditional cars with some add-on makes sense with 26262. SOTIF probably for the ADAS systems and that next kind of evolution. SOTIF, I think, is the way that makes sense and going forward. But I'm not sure even SOTIF has the kind of vision and breadth for fully autonomous systems, which I think is why we're seeing the UL 4600 kind of approach and standard now being looked at the far end of the path. So, if we're struggling at the moment to get 26262 kind of implementations on some of the advances in technology, SOTIV being that first kind of port of call, that next high level up, uh, there's a level beyond that which we really are going to have to see in vehicles to address some of these long-term safety concerns. Um, there's a big difference between having a fleet of 5 cars with people ready to grab the wheel if something goes wrong, and millions of cars driving people all over the place day in, day out, doing billions of miles a year. Those two things are very, very different, different problems to try and tackle.
And from a cert perspective, it's certification standards by their very nature are always going to lag the technology, right? Because it takes so long to get consensus and approvals and finally ratify them and publish them. Is that then going to hold up the deployment of autonomy, do we think?
I think it's a possibility, right? I actually think legislation might, you know, this type of thing is going to flip how we do insurance, how we manage infrastructure. This is going to flip everything upside down. I think legislation might be something that slows things down before safety standards. What comes first? The legislation to drive the safety standard or the safety standard to influence the legislation? I actually think it's government regulation that might have to change and drive the standards down. It can't be a self-certified like has typically happened in automotive, right? You almost need a governing body to enforce and to make sure that what's being deployed on the roads is safe.
In fact, you need the opposite. You need, for example, in Europe, you have there's a set of legislation that governs vehicles. That's the Geneva legislation that actually says you cannot have a system in a car that prevents the user from doing things or the driver from being responsible. So the never mind having legislation to enable, you have to have legislation enacted to prevent the disablement of some of the technologies that we're talking about.
Thanks, Damien. That's all the time we have for part one of this podcast. Tune in for part two to hear more about keeping AI and autonomy safe.